Let's talk about open ocean. The open ocean is an area of the ocean that includes any part of the ocean that lies away from the shore. Covering over 70% of the Earth's surface, the open ocean plays a crucial role in regulating climate, supporting diverse marine life, and influencing weather patterns. The open ocean is characterized by extreme depth, reaching down to thousands of meters, with the abyssal plains being the deepest part. Via temperature ranging from the surface warm to cool depth, the open ocean can be divided into 5 regions, which are Pacific Ocean, Atlantic Ocean, Indian Ocean, Antarctic Ocean, and Arctic Ocean. The open ocean is the largest ecosystem on the Earth, covering 64% of the ocean and 45% of the entire Earth. The ecosystem of the open oceans are very complex, self-sustaining, and interdependent community of marine plants, bacteria, and animals. It can be divided into 5 distinct zones according to depth, each of characterized by different physical. As you can see from the picture beside me, the open ocean can be divided into 5 zones. The first zone is the upper open ocean, ranging from the surface to 615 feet deep. The second zone is the middle open ocean, ranging from 650 to 3,300 feet depth. The third zone is the lower open ocean, ranging from 3,300 to 13,000 feet deep. The fourth zone is the abyss zone, ranging from 30,000 to 20,000 feet deep. The last zone is the deep ocean trench, ranging from 20,000 feet and deeper. All these 5 zones are characterized by different physical properties, including light, availability, and pressure and temperature. The base of the open ocean food web is formed by phytoplankton, which directly or indirectly support all other life in this ecosystem. However, due to the human activity, climate change, and many other factors, the open oceans are now currently facing many challenges to sustain themselves as a whole ecosystem.
The open ocean is the largest ecosystem on Earth. It includes 64% of the oceans and covers 45% of the entire Earth's surface. It provides a crucial habitat for thousands of species, from microscopic plankton that form the base of the entire food web, right up to the largest animal that has ever lived, the blue whale. Some animals spend their entire lives near the surface, and others in the dark, thousands of meters deep. The open ocean is characterized by highly mobile species, some passively drifting across ocean basins on currents, others actively undertake huge vertical migrations, making deep dives in search of food. The open ocean also shapes global climate and weather patterns, and is a vital carbon sink. Although humans have only explored 5% of the ocean, our impact is clear. The number one threat to the open ocean is industrial fishing, with nearly 90% of commercial fish stocks now fully or overexploited. Large pelagic fish species, including sharks and tuna, have experienced particularly drastic declines. 640,000 tonnes of fishing gear is lost or abandoned at sea each year. This ghost gear makes up 70% of the macroplastic pollution found in the ocean and results in entanglement, injury, and death of marine animals. The delicate balance in the open ocean is starting to shift, with ocean dead zones and jellyfish blooms increasing. The effect of human activities is starting to show. You can help by learning more about the seafood you are eating. Become a responsible consumer by reducing and diversifying the seafood you eat. Source your seafood from local and small-scale artisanal fisheries who use low-impact fishing methods such as pole and line. These methods reduce bycatch and minimize ghost gear. Governments around the world are working on the UN High Seas Treaty, which would create international marine protected areas in the open ocean and safeguard marine life across the largest ecosystem on Earth.
Number 5. Destruction of habitats. Some habitats provide and represent a unique shelter for reproduction. Marine forests are being destroyed for various reasons, including the use of aggressive fishing gear and methods like trawling.
Current might be close to collapse. That's according to a new study in the journal Nature Climate Change. A collapse would be a really big deal for the climate, and let me explain why. So the AMOC, A-M-O-C, stay with me on this, Atlantic Meridional Overturning Circulation. It's a really important ocean current that transports warm saltwater from the tropics up into the North Atlantic. Then the cold water comes back around to the ocean floor moving southward. It's kind of like a conveyor belt. So the AMOC is really important because it transports nutrients that sustain ocean life and distributes warmth around the globe. It's been slowing down for a little while, but in this study, researchers say that a tipping point is imminent if global temperatures continue to rise, and the current could stop completely. Now, it's ebbed and flowed in the past, even stopping before, but that was thousands of years ago during the Ice Age. In today's world, a collapse would mean a huge shift in the climate over a relatively short period of time. We're talking around 30-degree temperature average drops in Europe, dramatic droughts and sea level rise in the US, and stronger hurricanes along the East Coast. The study's authors said that a collapse could start as early as 2025 or as late as 2095. It's uncertain. The potential for collapse is just another reason to curb our greenhouse gas emissions worldwide.
One. Plastics. The ocean is increasingly becoming a plastic soup that is killing hundreds of marine animals on a daily basis. Sooner or later, these millions of plastic pieces will end up in our stomachs. The size of the Great Pacific Garbage Patch ranges between 700,000 square kilometers, 270,000 square miles, and 15 million square kilometers, 5,800,000 square miles. These products cause irreversible and fatal changes to the species. For example, they affect the reproduction process. Also, if ingested by humans, they can cause health issues.
The lionfish. They've gone from population 0 to top predator in mere decades. Scientists say that on some reefs, lionfish are killing off up to 80% of young fish. And in some Atlantic waters, they make up nearly 40% of the total predator biomass. Not long ago, they made up 0%. This leads us to the question: how did lionfish end up so successful here, where they don't belong? And where did they come from? The theory is, in the 1980s, lionfish living in home aquariums were released off the coast of Florida.
Somebody took this species that had never, been found naturally in the Atlantic Ocean and dumped it in. And it just took off.
Over the past few decades, they've spread up and down the Atlantic coast and Caribbean, from North America all the way down to Brazil. And there are records of lionfish in the Mediterranean, introduced separately via the Suez Canal.
the southern resident killer whales that live in the waters off my hometown of Vancouver. When researchers studied these and similar killer whales, they found that they spend between 18 and 25% less time feeding in the presence of loud boat noise. And that's a lot for a species that's already struggling to find enough food to thrive. Think of all the sounds we inject into the ocean. Air guns produce loud blasts. Then there's the sound of the actual drilling for oil and gas, the construction of things like offshore wind farms, sonar, and of course, the nearly constant drone from more than 50,000 ships in the global merchant fleet. In 2017, the Vancouver-Fraser Port Authority started asking ships to simply slow down when going through the Harrow Strait. In that 2017 trial, most of the ships complied, adding about half an hour to their travel time and reducing noise by about 1.2 decibels or 24% of noise intensity. This is important. Noise isn't just an irritation. It can cause chronic stress or even physical injury. It can affect marine life's ability to find food and mates and to listen out for predators and more. And I'm not trying to tell you that noise is the biggest environmental problem on the planet or even in the ocean. But the point is that humankind has a lot of impacts on our environmental system. And these impacts don't act in isolation. They act together and they multiply. So even for the ones that are not so obvious, we really need to pay attention to them.
How do you explain ocean acidification? Essentially, you add carbon to the atmosphere. The more you add to the atmosphere, the more will dissolve into the ocean. This will basically release more hydrogen protons into the water, and that essentially makes it more acidic. What does that mean, though? It means lots of things. Bivalves, clams, mussels, they're all made of calcium carbonate. And that carbonate part, that's the part that contains the CO2, right? But the ability to form calcium carbonate is based on how acidic the ocean is. If it's too acidic, calcium carbonate does not form very easily, and it takes more energy to do it, and it dissolves quicker. Anything that's made of calcium carbonate, all those hard-shelled organisms, they're going to struggle and are already struggling quite a bit just to be able to remain viable. And we're not even talking about ocean warming or those types of changes as well, even though they're all sort of come together. But it turns out that the lowering of the pH or the increase of the acidity in the ocean is affecting a lot more than that. And we're going to discover so much more in the next coming decade in terms of what this really means. We'll see what happens as time progresses.
Number 4. Overexploitation of fishing resources. Studies indicate that there has been a considerable reduction in the populations of some species of fish. In addition to overfishing, there is also a serious lack of fishing activity management or non-compliance with the rules. Overfishing of species with long life cycles at the top of food chains, like sharks and tuna, or species used for luxury cooking and alternative medicine also cause irreversible changes in the harmony of marine life.
So now we are moving on to the suggestion and recommendation on how the ecosystem can be better utilized. First of all, we need to implement protected area to conserve critical habitat like mangrove, seagrasses, and coral reefs. These habitats support a high diversity of marine life and provide important ecosystem service such as coastal protection, carbon storage, and nursery ground for fishes. We also need to promote restoration projects to recover damaged ecosystem and enhance their resilience to future disturbance. We need to reduce greenhouse gas emission through clean energy initiative and carbon sequestration. This will help slow down the rate of global warming and its impact on the ocean, such as sea level rise, temperature change, and the extreme weather event. We also need to develop adaptation strategy for marine species and ecosystem to cope with the changing ocean condition, such as shifting distribution, altered food web, and reduced productivity. We need to enforce stricter regulation on industrial and agricultural runoffs to prevent contaminant from entering the ocean. This contaminant can harm marine life and human health. by causing eutrophication, algal bloom, hypoxia, and disease outbreaks. We also need to increase effort in oil spill prevention and response and reduce plastic waste through recycling and reduction initiative. Plastic waste is a major source of marine litter that can entangle, injure, or kill marine animals or be ingested by them. We need to strengthen ballast water treatment regulation and monitoring to prevent the introduction of non-native species. These species can compete with or prey on native species, disrupt ecosystem balance, and spread diseases. We also need to support research and management programs to control invasive species and protect native biodiversity. Next, we need to combat IUU fishing for improving surveillance and enforcement of fishing regulation. IUU fishing stands for illegal, unreported, or unregulated fishing that undermines fishery management and conservation effort. We also need to encourage sustainable fishing methods and quotas to maintain fish stock at healthy level. This will ensure food security, livelihood, and economic benefit for present and future generations. We also need to implement noise reduction technology in shipping and exploration activity. Noise pollution is a form of acoustic pollution that can interfere with the communication, navigation, feeding and reproduction, and even survival of marine animals, especially those that rely on sound for this function. We also need to establish quiet zones in sensitive marine area to protect sound-dependent species.
So, in conclusion, the open ocean ecosystem is indispensable for maintaining life on Earth, providing crucial services like carbon sequestration, oxygen production, and supporting marine diversity. Yet, it faces severe threats from overfishing, habitat destructions, pollution, and climate changes. To better utilize and protect this ecosystem, we must enforce sustainable fishing practices, establish marine protected areas, reduce pollution through improved waste management and regulation, mitigate climate change's impact, promote responsible tourism, and raise awareness about its significance. Implementing this action is essential for preserving the health and resilience of open ocean ecosystems, ensuring their continued benefits for current and future generations.